The other thing we want to talk about today is a little bit more detail with inverse trig functions. Now, we have used inverse trig functions in the past to find angles, and we still want to think of that. Here. But in the meantime, we have also put angles in all four quadrants and converted those angles, expressed those angles in not only degrees, but also in radians. I know we spent a total of like a week talking about radians, but it's fine. We got to take some time to get used to the degrees and radians. So we use inverse trig functions to find angles. The angles can be measured in degrees or in radians. Let's use theta if we want degrees and x if we want radians. So what I mean is that if I say sine of theta is equal to 1/2, then theta is 30 degrees. Naming the angle theta is a request for degrees. But if I say sine of x is equal to 1/2, then we will use radians. So sine of theta is equal to 1/2. That will tell us theta is 30 degrees. Sine of x equals 1/2. That means we're going to be using radians. So x is pi/6 radians. Remember that when we're writing radians, we don't actually write radians. We just write the pi/6. Radians doesn't get to be written down as units. So unfair. The other thing that we've done since we first introduced the idea of using an inverse trig function to find angles is we have introduced non-acute angles, angles that didn't fit inside of right triangles. That was the original context for using inverse trig functions, was to find acute angles in right triangles. But now we have angles that can be measured in degrees and radians, and they can be anywhere in the whole circle, in any of the four quadrants. So we're going to have to learn how to solve trigonometric equations. I think this is the easiest way to sort this out. To think about it this way, that inverse trig functions are going to give us reference angles. The inverse trig function is going to give us a reference angle. Sines plus or minus will give us quadrant information. So the sines will give us the quadrants. So the plus or minus will give us quadrants. The inverse trig function will give us a reference angle. Then all we have to do is put the reference angles into the appropriate quadrants. So this is going to become an exercise in putting reference angles into quadrants. So this is one level up from using the inverse trig functions to find acute angles. Now that the angles can be anywhere, we're going to use inverse trig functions to find reference angles and sines plus or minus to obtain quadrant information. Then we just take the reference angles and put them in the appropriate quadrants. One level up from that is to realize that trigonometric equations could have an infinite number of solutions. So for example, if we go back to the function we had at the beginning, if I take any one of the equations that we wrote, it said solve that function equals 15. There are an infinite number of solutions. We see two of them, -2 and 18, but the period is 20. So there's also another solution at 38, another solution at 58, another solution at 78. There's also, going the other direction, a solution at -22, and it's also 15 at -42, and -62, and so on. There's an infinite number of solutions. So one level after reference angle in quadrants is the infinite solutions thing. So let's first do this reference angle in quadrant information. Let's suppose that I said the sine of 30. Oops. Why don't I just tell you what the solution is right away? Let's suppose that the sine of theta is equal to +1/2. When we see sine of theta is equal to 1/2, we know that the reference angle is going to be 30 degrees. If we use our calculator, ignore the plus or minus part of the 1/2 and just do sine inverse of 1/2 to get it to 30 degrees, if we forgot. It might be that we just forgot, we do a sine inverse of 30 degrees, but we know that theta reference angle is 30 degrees. Also note that I'm listing it as 30 degrees because I wrote theta in my equation. Theta says this is a degree equation. Don't worry about doing that all the time. I will say solve the equation for theta between 0 and 360. So there'll be additional information that indicates that I want degrees instead of radians. The other thing to note is that this sine of theta is +1/2. Since it's +1/2, we think that sine is positive in quadrant 1 and quadrant 2. So I'm going to take that 30-degree reference angle and put it into quadrant 1 and quadrant 2, and those will be my two solutions from 0 to 360. So my theta So this is one level up from using an inverse trig function to find an acute angle. Any questions? So in this problem, I haven't changed the reference angle, but I did change the quadrant information. Sine of theta equals 1/2. That means theta is a 30-degree reference angle. So the first thing we do is come up with our reference angle. And then we notice sine is negative in quadrant 3 in quadrant 4. Sine is negative when y is negative, and y is negative in quadrant 3 and quadrant 4. So I'm going to take 30 degrees and put it in quadrant 3 and quadrant 4. So 30 degrees in quadrant 3 is 210, and 30 degrees in quadrant 4 is 330. Reference angle and quadrant. Is everything okay? It's like one extra step from that inverse trig function stuff that we do. Because now we can want to find all the angles in the other quadrants as well. It's not the individual problems, it's the progression. Change one thing. Here, the one thing I changed, I went to cosine thing equals -1/2. So I've changed my reference angle. Cosine of 60 is 1/2. I'm not worried about the negative part. That's the quadrant information. Cosine and 1/2, that means we're talking about a reference angle of 60 degrees. And cosine is negative in quadrant 2 and quadrant 3. Cosine is negative when x is negative. That's in quadrant 2 and 3, the ones on the left. So now I'm going to take 60 degrees and put it in quadrant 2 and quadrant 3. When we're going to be solving trigonometric equations in general, there's going to be more instructions. Right now, I just want to find the reference angle and put it in the appropriate quadrant. So I'd say solve these equations for theta between 0 and 360. These are the two solutions that we want to get. I could ask you to solve equations in radians as well. So here in this equation, I would say solve for x between 0 and 2 pi. There's a couple of hints that we're going to be solving in radians now. First of all, I started using the letter x, and I usually use that for reserve that for radians and theta for degrees. So I'm using x. And then furthermore, I'd say solve for x between 0 and 2 pi. That would be another indication that we're doing radians. So we might see cosine in 1/2 and think 60 degrees. And they go, oh, dang it, radians, pi over 3. We just switch it over to radians. So our reference angle, x reference is pi over 3. We're just thinking in radians. Still negative, so cosine is negative in quadrant 2 and quadrant 3. So now I just take the reference angle and put it in quadrant 2 and quadrant 3. Pi over 3 in quadrant 2 is 2 pi over 3. As I take pi and subtract pi over 3. 3 pi over 3 minus 1 pi over 3 is 2 pi over 3. And pi over 3 in quadrant 3 is 4 pi over 3. Now this we either just remember or we think about what we need to do. We go from pi and then get into quadrant 3, we add our reference angle. So pi plus pi over 3 is 1 1/3 pi, otherwise known as 4 pi over 3. So we get those either because we are thinking in degrees and just translating quickly, because 120 is 2 pi over 3 and 240 is 4 pi over 3. Or we start thinking in terms of radians. Questions? Is everybody okay? Let's suppose that I ask for cosine I equals negative 0.4. We recognize that 4/10 or 2/5 is not on our list. So this is not from a 30-60-90 triangle or a 45-45-90 triangle. That means we're going to have to call in some calculator backup. I don't remember what the reference angle is. So in this case, since we don't recognize the reference angle, we're going to have to calculate the reference angle. First, I'm going to make sure that my calculator is in radians. It looks like it is. And I'm going to get my reference angle with an inverse trig function, cosine inverse. Now I'm only concerned about the 0.4 because I'm just going for the reference angle. So cosine inverse of 0.4. I don't worry about the negative because I'm trying to get a reference angle. And it looks like cosine inverse of 0.4 is 1.159. Let's go 4 significant figures. This negative is still, cosine is negative in quadrant 2 and quadrant 3. So I'm going to take my reference angle of 1.159 and put it in quadrant 2. Remember, we're dealing with radians, not degrees. So instead of 180 being between quadrant 2 and quadrant 3, it's pi that's in between quadrant 2 and quadrant 3. So 1.159 in quadrant 2 is going to be pi minus 1.159. Pi is 3.14, so 3.14 minus 1.15 is 1.982. That's reasonable. But then I need pi 1 over 1.159 in quadrant 3. So that's going to be pi plus the 1.159. That'll be 4.301. In this case, I might notice that this 1.159 has been rounded off. And so if I want to get the 1.159 and all the rest of it over again, I could just cosine inverse of 0.4 and then do pi plus the answer. Or I could have just gone from the beginning, pi plus cosine inverse of 0.4. But what I want you to think first is ignore the plus and minus, use an inverse trig function to find a reference angle, put that reference angle in the appropriate quadrants. Any questions? Comments? Any thoughts? Snide remarks? Astute observations? Epic poem? Okay. Of course we're okay. It's like almost 2:30. I don't think I've ever gone past 2:30. And we're walking into a 4-day weekend. I could do whatever I want right now and no one be asking questions. I can be like, all right, now let's cover some calculus 3, which is multivariable calculus. And we're gonna have a quiz on this on Tuesday when we get back. And still people will be like, oh, nah, no question, we got this. I'll worry about that quiz on Tuesday because it's a 4-day weekend. I'm just kidding. I'm not going to give you a multivariable calculus quiz on Tuesday. It's single variable calculus. I'm just kidding. Single variable calculus is way too expensive right now because of the supply chain. Oh, wait, no, that's single barrel scotch. That's something else entirely. Any questions? I'm also just kidding. I don't drink scotch. That's disgusting. I think people that drink scotch are liars. They're like, oh, this is an excellent one. It's like, well, no, incorrect. That tastes like rubbing alcohol. This is partially because I don't really have a lot of sense of smell. Therefore, I don't have a lot of sense of taste. Makes it dangerous to eat my cooking. I have to be very safe. It's just going to be too spicy. If it's going to be spicy at all, it's going to be too spicy because I keep tasting it until it becomes spicy enough. But since I have reduced taste buds, it becomes any questions? All right, that's the one level up for what we do when we're solving trigonometric equations. We use inverse trig functions to find reference angles. We use plus and minus to put things into quadrants. We're going to add more to this, so this is what we want to practice over the weekend. Practice over the 4-day weekend. So come back on Tuesday and we'll do some more of this and look at some variations. So that's going to do it for today. That's going to do it for this week. I'll see y'all on Tuesday. Everybody have a good weekend and thanks for playing.